Hello everyone, my name is Vitor Albiero and I'm a PhD candidate at University of Notre Dame. And I'm going to be talking about the paper that I did with my colleagues from Facebook AI with the title Image to Pose, Face Alignment and Detection via 6 Degrees of Freedom Face Pose Estimation. So in a traditional pose detection pipeline, we have an image that contains many faces. So the first step is to apply a face detection model where bounding boxes are estimated for every face. And with this bounding box, faces are cropped. And then a second model is applied to do landmark detection. And with these landmarks, we can either align their faces, or in this case, we can estimate 6 degrees of freedom. So we want to simplify this process by using that same image that contains many faces. We apply a single model that performs multi-face 6 degrees of freedom detection. And now every face can be aligned, as you can see in the image on the right, without prior face detection model or even the use of landmarks. So the key observations to why use 6 degrees of freedom. With landmark regression, in this case, we have 10 dimensions to be regressed. For a bounding box, we have 4 dimensions, but for 6 degrees of freedom, we only have 6 dimensions, which is just 2 extra dimensions compared to a bounding box. But with a 6 degrees of freedom, we know the face size, location, and rotation. And with that, we can project bounding box that are customizable. So we can use more or less of the face, more or less of the forehead, and this is not possible with a simple bounding box regression, and is cheaper to regress 6 dimensions than is to regress 10 dimensions compared to a landmark regression problem. So our proposed method, starting with an image containing many faces, we apply a modified faster RCNN to it, which outputs global pose and faceness score for every face present in the image. And the key contributions to this modified faster RCNN are a pose conversion algorithm that converts from global to local pose, and this allows us to maintain consistently across proposals when training. Also, bounding blocks are projected from the pose. We perform a pose loss that is based on the 6 degrees of freedom being regressed, and we add an additional calibration points loss that is the points projected using the 6 degrees of freedom against the ground truth that's also projected using the 6 degrees of freedom labels. So in here, we have some qualitative results on AFW 2003D. On the left, we have the ground truth. On the right, the image to pose. And we can see here that our model regress the 6 degrees of freedom very close to the ground truth and is able to perform across a variety of different head pose as seen in this image. Now, some qualitative results for wider face, where we have multiple faces in every image. We also have very occlusion, as we can see on the left top image. We have tiny faces as in the basketball scene, and our model is able to detect and estimate the 6 degrees of freedom across all these scenarios. So the conclusions of our paper: we propose a novel approach to 6 degrees of freedom estimation that does not require a face detector. It also does not rely on landmarks. It can run on real time, and we achieve state-of-the-art on head pose estimation across 2 benchmarks. And we also achieve state-of-the-art on face detection on wider face when comparing to models of similar complexity. So if you want to know more, please come to our poster section. We would be happy to discuss the details of the paper. Also, the code, data, and models are available on our GitHub, and just scan the QR code if you want to use our data code and models. Thank you so much.